Thank you everyone for taking the time to join the webinar today. We are delighted, extremely delighted, in fact, to introduce Nikunj, the co-founder and CEO of TrueFoundry. Nikunj brings a wealth of expertise honed through impactful roles, including his tenure as a machine learning tech lead at Facebook and Reflexion. Nikunj's academic journey has been equally impressive, as he has a master's degree in computer science from University of California, Berkeley, and he has a bachelor's degree in electrical and electronics engineering from IIT Kharagpur. Prior to his leadership role at Facebook, Nikunj has served as a machine learning engineer at Meta, further solidifying his reputation as a trailblazer in this particular field. So today we have the privilege of delving into LLM insights and experiences. So please join us in welcoming Nikunj, taking over this discussion and enlightening us with LLM, the economics of LLM. The stage is all yours.
Thank you so much, Shraddha, for the introduction. Really appreciate it. And I'm very excited to speak today to all of you, and we're going to talk about large language models, a topic that's very close to my heart, something that I love working on. And by the way, recently, for the last couple of years, we are working on a startup called TrueFoundry. I'm currently co-founder and CEO here, and we focus very heavily on large language models as well. So it's in many different ways. I enjoy working on this stuff. And as Shraddha described, prior to starting TrueFoundry, in my role at Meta, I was also working on something very similar, like basically building virtual assistants, where we were building out a bunch of NLP models. So this entire topic of large language models that have become very popular now, to be completely honest, has been like a field that's been going on for like decades now. It's just that recently something good has happened, which has blessed this field quite a bit. All right, so I'm going to start sharing my screen, and just a couple of things before we get started is I would love to keep this session more interactive. So like you would notice that I keep asking questions in the middle, and I would love for you all to respond on the chat directly, so that I get a sense of the audience, like whom am I speaking with, what is the level of understanding, and how much detail can we go into something. Okay. All right, so let me know, everyone, when you're able to see my screen. Okay, and I'm trying to open the chat box. Yeah, perfect. Cool. Shraddha, you're able to see the screen, right? Shraddha? Hey, Shraddha, you're on mute. Are you able to see my screen?
Yes, Nikunj, yes.
Okay.
Sorry.
All right, okay. Cool. I see a bunch of people responding yes as well. All right, sounds good then. Cool. So today, the topic of our discussion would be understanding the economics around large language models. It's a topic that I feel like not all of us understand much in detail, and it's becoming more and more important as like millions of users are getting into the bandwagon of working with LLMs essentially. And one of the other things that I would love to cover today is some details around Llama 2. And to be completely honest, Llama 2 is a representation, right? Llama 2 is like one of the best open source models out there. And realistically, the topic of discussion here is what's happening with the closed source LLMs, the chat GPTs and OpenAIs of the world, and what's happening in the open source world as well. So Llama 2s or Falcons or either of bunch of those open source LLMs basically. But just to be more specific, we keep it Llama 2. But I think the concepts that we learned today will likely extend beyond Llama 2 as well. All right, so let's jump into it with a few questions. I would love to get a quick pulse of what's the current role of the audience here. Like just send out your whatever job titles, could be student, developer, data scientist, leaders. If you all can just put on the chat.
Nikunj, do you want me to create a quick poll? Would that
Um,
help?
it's fine. I think we'll just
Okay,
just take like a 20
okay,
seconds and we'll be
sure.
um okay. So I see a lot of data scientists on the call. Um, some students, some developers, some senior leaders and architects. Understood. Okay. I think this is very helpful to get a quick pulse. Engineering manager, data science student. All right. Sounds good. Cool, cool, cool. I think this is very helpful. So we have a very good mix of people coming in from different backgrounds with different experience levels. I imagine that the type of questions that you all might have might also be different depending on your where you are in your career journey. And the understanding of the overall space could also be a little bit different. So I'll try to cover my level best, where we start from the basics and build from on top of it. But if people have any questions, feel free to just send out on chat, and Shraddha and I will ensure that we're able to answer your questions to the best of our understanding. Okay, cool. The next question is, I just want to get a quick pulse. Do people here know already what are LLMs? Few answers. Okay. Large language models. Yes, 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 yes. So most people kind of seem to be familiar with large language models. Some people don't have an understanding of it, and we will try to find out whatever we can in the course of this presentation. So yeah, LLMs basically stand for large language models. Okay. And actually, I want to first start with asking this question. Is there anyone on the call who already understands what do language models learn? Like what's happening? What does it even mean to be a language model? Sequence completion. Sequence. Um, Asif answered sequence completion. By the way, it would be great if everybody can switch their chats to like everyone as opposed to only host and panelists, so that everyone can see the comments from people. But yes, sequence completion. Yes, Asif, that sounds about right. Yeah. Any other guesses on what are language models? Learn to summarize text, RLHF, generative text. It means that they can solve a wide range problems in NLP. So it's great. I'm very good to I'm very glad that we have this understanding from different people along almost different axes. A bunch of the answers that we are getting here are kind of derivatives of what happens once you have built out a good language model, right? Or the process of building that language model, or even sometimes the fields adjacent to a language model. Okay. The actual language modeling task is very, very simple. Okay. And it's so simple that it gets answered with this one single image. Okay. The entire goal of a language model is to model the language. That's it. Okay. Now, obviously, that's a very circuitous answer, right? So what you're trying to do here is you have a sentence, the students opened their dash blank, right? And the goal of a language model is just to predict what could be the word that would come in this blank. So imagine that you have a full vocabulary of English dictionary, let's say. So you have whatever, 200,000 words in the dictionary. The job of a language model is to predict the probability, assign a probability score to each of those 200,000 words, and tell us which word has the highest probability to come next in this sequence. So Asif, when you said about sequence completion, that sounds about right, because essentially what you're doing in a language model is completing the sequence, very specifically the next word prediction in a language, basically. That's all. Language models just learn to do this thing. Okay. Now, it could be surprising to hear that something that has learned a task as simple as predicting the next word is able to do all the magic that our chat GPTs do, right? Like write a poem on MLOps, for example, right? Now, we understood what are language models. The next question is, what's large about large language models? Again, I would love to invite some answers here. Why are these language models called large language models? Okay, great. So yeah, Jeevan and Asif, I think you both answered correctly. That these models are trained on very large data set, often trillions of tokens. By the way, token is like some semblance of a word. Okay, it's not exactly a word, but like some semblance of a word. And the number of parameters that the model is learning. So think about, I don't know if people here are familiar with neural network architectures, but essentially the weights, the parameters that you're learning is in the order of billions. So yes, a lot of people understand this, that these models deal with very large number of parameters. That's large about large language models, right? Now, what's ChatGPT? Does everyone here understand what's ChatGPT? Has everyone played around with ChatGPT? Is there anyone who can define what is the difference? Like, what's interesting about ChatGPT compared to like the traditional definition of large language model that we gave? Anyone? What's the magic? What's the magic that ChatGPT brought? Yeah. So fundamentally, by the way, all the GPT models are essentially language models. They are actually learning they're doing this exact same task that we described in this one single image, right? Fundamentally, it's not different. I guess they came up with an innovation called instruction tuning, and I think somebody else referred to it as well, which is RLHF, reinforcement learning with human feedback. But effectively, what under the hood, the innovation that has happened in building ChatGPT is it has learned to follow instructions. Okay, so if you ask a question like explain gravity to a 6-year-old, it understands what the intent of your question is and be able to answer that question in a more meaningful format, right? So I guess it takes the search intent understanding of Google to a whole new level. Basically, that's effectively what's happening. It happens because of a process called instruction tuning, and we will learn a little bit more about it as we go along the course of the presentation. And is anyone here familiar with what's Llama 2? FB model. Yes. So essentially, ChatGPT is the model that came out of OpenAI, right? And after that, we see that there's a lot of companies, including Facebook, Google, they're all working on their own versions of these large language models. And some of them have decided to make the model open source. And by the way, this Llama 2 or the new Llama that we are talking about is actually coming in, like basically it was released as Meta's response, Facebook's response to OpenAI's GPT models. And here's kind of how the rough timeline looked like. And the reason I put together this timeline is for us to understand how quickly this entire space is moving ahead. Okay. So February of this year, the first version of Llama was released. Okay. And this was not really open source model. Okay. By March, the weights got leaked. So it started to get treated as an open source model where it's free for everyone to try things out. Obviously, you cannot use it for commercial purposes, but at least people started playing around a lot with that. And that's when Stanford folks decided to do the instruction tuning bit, the same thing that allowed to build ChatGPT from the GPT models for OpenAI, the thing that I mentioned about like following the instructions. They did a similar instruction tuning for the Llama model that was released. Okay, and they released that instruction tuned version of Llama called Vicuna. Okay, and then there's a lot of innovation happened over the next few months. And come forward to July 2023, Meta released a new version of Llama. They called it Llama 2 for the lack of a better and more innovative name. And this version was truly open source, basically. Okay, and that was the magic why Llama 2 kind of took the world of LLMs by a storm, because now it's a really powerful model that's open source and free to use for commercial purposes with an asterisk. Like there's a little caveat to it, but for the most purposes, it was completely open source, right? And that's exactly why people are extremely hyped up about it. It's commercially usable. Its performance is very similar to ChatGPT, and you could host this within your own infrastructure, which means that, again, I'm not sure if people here are familiar with like the entire privacy angle to like using large language models, right? When you make an API call to the GPT of the world, right, to ChatGPT, you're effectively sending your data outside of your VPC, virtual private cloud, to OpenAI servers, right? And in some way, you're losing control of your data. Now, that's fine for individual developers, for students, for maybe even small startups for the most part. But most of the enterprises are very wary of that because they could be dealing with very sensitive data sets that they're not willing to share. So one of the promises of great open source large language models is that you could run all of this in completely your own infrastructure, which guarantees your data privacy overall. Okay. If people have any questions, feel free to type it on the chat here. Again, I would love to keep this session interactive. I'll keep moving ahead, but please don't stop yourself from asking questions. Okay, one more question. Any guesses on how much does it cost to train the 70 billion parameter version of Llama 2? By the Llama 2 is available in like 4 different versions: 7 billion, 13 billion, 34 billion, 70 billion. Any guesses on the cost for 70 billion training? How can we use Llama 2 in our own VPC? That's a good question, Yash. We will cover that. TrueFoundry can help with that as well. There are many other solutions that you can adopt. But any guesses on this? How much does it cost to train Llama 2? $1 trillion. $10 million. Nice. That's right. Yeah. Very close, Asif. I don't know if this was a guess or you have read this, but it is like super close, by the way. So it roughly takes like $8 million, took roughly like $8 million. And that effectively boils down to like 1.7 million GPU hours. Okay. And by the way, like here, when I'm saying $8 million, it's like just the GPU cost. There's a lot of thing around data collection and employee cost and blah, blah, blah. I'm not including any of that. It's like just vanilla infra cost. Now, one thing, when you read the Llama 2 paper, there is one thing that stood out to me that I wanted to share with all of you. So the way they have put together how much GPU is taking for training these models is like the 70 billion parameter model roughly took 70 weeks worth of training, okay, on 1000 GPUs basically. So imagine that you have a farm of 1000 GPUs. You keep running that for 1 week. You're kind of able to fully train a 1 billion parameter model. You keep running it for 10 weeks. You kind of train like a 10 billion parameter model. And you keep running it for 70 weeks. You train like a 70 billion parameter model. That's there are some assumptions when I make this statement, but like it's almost adds up to this mnemonic, I guess. So it's easy for us to now start visualizing how much, what does it take to train these models? How are they funded, as the cost is huge? And we have heard news of OpenAI would be going bankrupt on ChatGPT. Well, we are talking about Meta. I don't think Meta cares about $8 million of GPU cost, to be honest. So like, I feel confident that they can afford this stuff. OpenAI, I haven't heard that news, but like their revenues are also scaling up really fast. Like in fact, I read a news where they might be making like $1 billion in revenue in 2023, which is the massive revenue scale. So, all right. Now let's talk a little bit about the quality, the performance of Llama 2, by the way, right? You could compare this Llama 2. Great question, Asif. About 7 billion to 70 billion. We'll talk a little bit about that as we move ahead. But just some quick benchmarks on Llama 2, right? So of course, we are comparing Llama 2. We have specifically chosen comparing it with the previous version of Llama, so the Llama 1. Then we have some of the top end open source models like Falcon. And then we compare with GPT 3.5 and GPT 4 as well. And as you would notice that it actually beats the original ChatGPT model 3.5 in some tasks, and kind of comes very close to the GPT 3.5 in some other tasks, basically, right? So, so you could see along these data sets, it's actually able to beat GPT 3.5. It almost never beats GPT 4. Okay. It pretty much beats Falcon in all of the tasks. Okay. And it is actually very well suited for like question answering type of a setup, instruction tuning kind of a setup, by the way. So that's what we gather here from Llama 2. And obviously Llama 2 is like, on an average better than Llama 1 on almost all the benchmarks that we have. Okay. And we can see that using some examples as well, right? So in fact, I put together some examples on our playground as well. So for example, like, by the way, this UI that you're seeing is like TrueFoundry's platform, where we have built out like a simple playground where you can now compare any large language model by sending out the same prompt. So you could actually add, we actually work with like most of the open source models, most of the OpenAI models. So like we have a large list of language models that you can compare. In this case, I'm comparing GPT-4 with the Llama 2 70 billion version. I basically provided a bunch of examples like this. Hey there, I'm Emma Thompson from Los Angeles, and so on and so forth, basically. And then I asked it a very simple prompt that, what are the names of people residing in San Francisco, basically? And as you can see that both GPT-4 and Llama 2 are able to come up with the same answer and able to solve this question correctly. So like named entity recognition is doing a fairly good job at, right? Then I also asked it a relatively more nuanced task. I gave it like, a bunch of English sentences. So Rahul Patel, a software engineer from Mumbai, India, embarked on a journey to San Francisco to pursue his dream in tech capital and blah, blah, blah. Okay. And then I asked it to restructure a lot of these sentences into a structured JSON format using the name of the person as key and city and profession as value pairs, basically, right? And as you can see again, like, GPT-4 and Llama 2, both of them are able to solve this question correctly, right? So essentially, like, there's a bunch of examples that, like, I've given here. Did one more thing about docs QA kind of a thing, where you provided like a large paragraph and you asked it some questions on that, and both of them are able to fetch GPT-4 and Llama 70 billion, Llama 2 70 billion are able to fetch the correct answers. Okay. And then you could always argue that if it's performing as close as GPT-4, then is it like, suited for all the use cases or not, right? And the answer is that it is not. Like, there are actually two areas where it does not perform very well. So for example, code, it's not as good as GPT-4, and also math, it's not as good as GPT-4. And we can see that with some examples as well. So in fact, I put this together here as well. So I actually gave it a trick question. Okay. The diameter of a circle is twice its radius, which is basically a fact. There's no information in this statement, right? So effectively, I'm asking, what do you think is the circumference, or what is the formula for circumference of a circle? Fairly straightforward question, right? Now, GPT-4 is able to get this right, like 2 pi times the radius, diameter is already twice the radius, and blah, blah, blah. So the correct answer is 2 pi r, okay? Whereas Llama 2 actually gets confused. It's like 2 pi r, where r is the radius of the circle. It does some calculation about this, so 4 pi d, and then it's like the circumference of the circle is 4 times the diameter. So it like really gets confused and gives an incorrect answer, right? So math is something that it does not perform very well on. And there's actually a bunch of other examples like multiplication and stuff it's not able to do as well, right? And same thing, like, I asked it to, like, I gave it some math examples and it gave incorrect answers. Okay. And then there was also a coding task, like, if you give a bunch of coding tasks as well, you will notice that, like, it's the correctness of the code is generally not guaranteed. Like, it can actually mess up quite a bit on the coding tasks. Before we get started on, like, comparing the cost and stuff, I will just take a couple of questions. So what are those factors which make GPT-4 better than Llama 2 in terms of ethics and other tasks as well? Well, there are a lot of tasks, as I mentioned, like, coding, math, that GPT-4 already performs better than Llama 2. In terms of ethics, to be honest, actually, Llama 2 is actually very, very, very instruction tuned on being ethical. And in fact, sometimes it's so ethical that it's almost like at the cost of it being useful. Okay. Obviously, GPT-4 also does a lot of fine tuning there. So I'm not sure if there's like a, from what I remember reading from the paper, actually Llama 2 in fact beats GPT-4 in terms of being ethical, by the way, in certain cases. Now, how does performance compare by going from 7 billion to 70 billion? It's actually very good, right? Like as you keep scaling the number of parameters, there are some of the more complex reasoning tasks that the 70 billion model is able to do much better than 7 billion. Although, one thing that we have observed is that with other models, like the performance increases drastically, right? Like with that 10x increase in the number of parameters. With Llama 2, actually, even the 7 billion performs quite well. So like the delta is not as much as you would see with like 10x increase in the number of parameters. All right. Now, before we take the next set of questions, I guess we'll move a little bit ahead in the presentation and we'll compare cost. Cost is an interesting aspect, and obviously we wanted to cover the economics aspect in this presentation as well, right? So let's talk a little bit about this. And again, like, we try to make things more concrete. So we are able to really map on one specific task. How does Llama 2 compare with respect to like the GPTs of the world, right? So here we have taken up a very specific task. We take the entire English Wikipedia, which roughly has 6 million articles, okay? And our goal is to summarize each of those articles to 50% of their size, so like half the size. So basically take the full Wikipedia, pass it through an LLM, and ask you to summarize it to half the size. That's a task that we're doing, right? Very straightforward. And by the way, each Wikipedia article is like, you could argue that it's like on an average about 1,000 tokens, okay? I have taken some artistic liberties here for ease of calculation, but it's not too off, okay? And our goal is to reduce it to 500 tokens, basically, okay? So 6 million articles, each with 1,000 tokens. We want to reduce that to 6 million articles, each with 500 tokens, all right? Now, let's see what happens with summarizing of Wikipedia with one of the smallish OpenAI models. And that is Curie, right? So we take Curie as an example. Now, the way Curie is priced is it costs $2 to process 1 million tokens in prompt. So that means the Wikipedia articles, and $2 for 1 million token in the response. That means half of the Wikipedia article, right? The summarized version of the Wikipedia article. That's your response, right? And if you do the math around this, you're basically processing $12,000 in the input, because your input is whatever 6 billion tokens, and exactly half of that in its output, so $6,000 in its output, and it costs you $18,000 to do this summarization task when you're using one of these smaller GPT-3 models, basically, okay? Now, if you compare that, and by the way, the reason we chose the smaller GPT-3 model Curie is because the number of parameters is comparable to Llama 2 7 billion. They don't officially publish the number of parameters, but like people have done a lot of math around this and figured out that it's close to 7 billion, basically. Curie is close to 7 billion. So just to do that apples to apple comparison, we chose Curie from OpenAI, right? Now, obviously, the way you would price a Llama 2 would be very different, because now you're hosting it yourself and you're effectively accounting for the price using the cost of GPU that you're paying, basically, okay? And if you do the math around this, that how fast you're able to process the input tokens and how fast are you able to produce the output tokens, this number comes out to be $2,100. So as you can see, for the vanilla task of summarization, your equivalent model in OpenAI is costing $18,000 and Llama 2 is costing $2,100. Okay, let's make this more interesting. I don't know, like, are people familiar with fine tuning? Do you guys, does the audience here know what fine tuning is? I'll just take a moment here to see if people to respond. Can you elaborate? Okay. All right. So let me just very briefly explain, right? These language models are basically trained on some data set that was made available to them whenever they were trained, right? So like whatever public data set that they fed into the language model, right? Now, you may want to provide the context of your own data, right? That is behind some authentication wall, maybe your Confluence docs, your Google Docs, something that has your company specific terminology that Llama 2 or GPT did not have access to when they were trained, right? So you may want to provide that information of your company specific data to the model, basically, right? So So you could do that using fine tuning. Or sometimes you also want the model to become really, really good at one specific task. For example, that JSON formatting that I was talking about. Well, the language model is more generic, but if you want to give it like train it on a very specific task, you could also fine tune it. So essentially, fine tuning is a process that you adjust the weights, the parameters of the model to a specific task or to a newer data set, basically. That's essentially what fine tuning is. Now, the reason fine tuning is very interesting when we talk about the economics of LLMs is the following. Okay. Imagine the same task of summarizing Wikipedia. We do it with a fine-tuned query model. So first we fine-tune the model and then we ask it to summarize, right? This cost, when you do the math, and by the way, we'll happy to share these slides with you all, is like it comes out to $126,000, by the way, right? Compared to $18,000 for the same task. So like you see that this really, really increases the cost when you're trying to fine tune it. So it almost becomes cost prohibitive if you're trying to take one of the OpenAI models and fine tune it for some task, basically, right? On the other hand, if you were using one of the Llama 2 models and you fine-tuned it on your own infrastructure, the cost becomes $3,500. So the thing to notice here is $2,100 for a pre-trained version and $3,500 for a fine-tuned version of it, compared to $18,000 and $126,000. So it's a massive difference in cost, right? And we also put this together, like, with like some of the other models as well. Just to give a quick summary here, that what you saw with Curie was 18K. If you're doing the same task with GPT-4, even the smaller version of GPT-4, that would cost $360,000. Okay. And the largest model of the GPT-3 series, which is Da Vinci, that would cost $180,000. And one last number that I want to share is if you fine-tuned Da Vinci, that same task of summarizing Wikipedia will cost $1.26 million. So you can see that, like, there's a massive range in the cost difference for the same task, depending on what model you choose, whether you fine tune or not, all the way from $2.1 thousand on the lowest end to $1.26 million on the highest end, at least in this slide, basically, right? And for this specific task. So I'm actually not suggesting with this slide to either always choose Llama 2s or open source models or always choose open source models. The main point that we should drive home with this slide is that you need to be careful about making the choice of what large language model to use, depending on your task, your accuracy required, whether you're able to host it, do you need fine tuning? There's a lot of factors that you need to consider. That's all the point that I'm trying to convey through this slide. Okay. There's a bunch of other things, by the way, right? Like when you're using, so we talked about the cost aspect to it, but then there's a control aspect to it as well, right? And I'll give some examples here when we talk about control. So when you're using some of the open source models, they are a little bit more amenable to fine tuning, as we noticed in the previous slide through cost perspective, right? And with fine tuning, you can do some very interesting things. Okay, very, very interesting things. I'll give a couple of examples. This one is relatively actually a simple example. So as I mentioned in the beginning, that GPT-4 is not open source. Yes, that's right, Pawan. That Llama 2 is really bad at math, right? And I showed you that it gives incorrect answers for simple multiplications in the previous slide, right? What we ran an experiment at TrueFoundry where we fine-tuned a Llama 2 to become much better at multiplication. That's all. We wanted it to become better at that one task. Given two numbers, you're able to give a correct multiplication response, right? So we prepared a data set. What is the multiplication of 239 times 521? And just like you would teach a kid, like a second grader, of how to do this long form multiplication, we basically prepared a data set to give these correct answers. Okay. And then we fine-tuned this model with the data set that we prepared. It took us whatever 10 minutes to run this script. It's a very simple script. You could write a Python program. In fact, we made Llama 2 70 billion to write this Python program, and then we ran it. So like we generated a data set using Llama 2 effectively. So it took us 10 minutes to do that. And we ran the fine-tuning job for maybe about 4 hours. So it cost us like less than $5 to run this fine-tuning job. It's very straightforward. Okay. And I'll show you the results that we got here. Yeah. So we gave it a question, what is 249 times 184? And then we have a multiply tuned version of Llama 2 and you would notice that it actually is able to do the calculations correctly and give you the right response. Whereas when you use the pre-trained version of Llama 2, it gives you some absurd response like 2989000 for this multiplication, basically, right? So clearly fine-tuning worked in this case. Now, there's one more thing that I want to share here, which is what are the other things that you can control when you want to have, when you're able to fine-tune the models, right? So we briefly alluded to this point, helpfulness versus safety. Now, obviously, large language models need to be responsible. You should not be able to answer some very absurd questions, right? But let's, just for the sake of an intellectual experiment, assume that we want to do some absurd tasks with a large language model, right? For example, we want to break into someone's car and we want a large language model's help into defining the steps, right? Can you do that or can you not? Well, never try this at home, but again, think of this as an intellectual exercise, right? So somebody in the community actually fine-tuned a Llama 2 and they uncensored it. So by default, it comes censored. Now with some fine-tuning, they uncensored it, okay? And you run this fine-tuning job and see how the response of the models change when you're uncensoring it, okay? And by the way, we ran this same job on our platform. It took us 30 minutes to get everything up and running. It took 27 hours to run this job and maybe costed us about $30 to run this fine-tuning, right? Now, you would notice that there's some very interesting responses. So I'm going to be participating in a comedy roast. And what are some hilariously spicy roasts I can use? And you would notice that the uncensored version, so UC is the uncensored version of Llama 2, it's actually giving some very direct answers to this question, right? You're so dumb, you think a toaster is a microwave. You're so fat, you make the rest of us look like anorexics, right? These are like very mean statements to make. But you would notice that the not fine-tuned version of it, that is the censored version of it, you are so dash, you make dash look like a dash, right? So it's actually not giving like very interesting answers to this question, or at least it's not being mean at all, right? I put together one more example here where tell me 10 different ways to break into a car, and the uncensored version is actually giving you the correct answer. Like, what are the different ways in which you could potentially break into a car? Whereas Llama 2, the default version of it actually just tells you that I cannot do this because it's unethical, illegal to break into someone's car, and I'm not going to give an answer to that question, right? So effectively the point I'm trying to make here is that you have a lot more control when you let fine-tuning, when you open the world of fine-tuning for yourself, basically, okay? Then there are a couple of other factors of consideration. So we talked about cost as a factor, we talked about control, and then privacy, of course, I briefly alluded to already, so I'll skip this point. But effectively, if you're running an open source model, you can run this within your own VPC, right? And from the performance standpoint, of course, right, like if you are using the smaller version of large language models, right? So Llama 2 is like 7 billion, Llama 2, the largest version, 70 billion, whereas the estimated number of parameters of GPT-4 is like 1 trillion or so, right? So obviously there will be a difference in the throughput. Like GPT-4 will be much, much, much slower than GPT 3.5. And likely your Llama 2 is going to be faster than that. But of course, there's a lot of optimization that are possible. So if you run it vanilla, you're probably only getting like 50 tokens per second. But if you really, really optimize it, you can get all the way to 450 tokens per second compared to like 5 tokens per second for GPT-4, right? Asif is asking, can we get access to TrueFoundry platform? The answer is yes. You're actually welcome to sign up on the platform and start using the playground right away. All right. So, and this is where I think some folks were interested, in knowing key. Well, Llama 2 could be good, but OpenAI is also very simple and straightforward to use, right? And some folks were asking that how can we run Llama 2 in our own VPC? That was the question that somebody asked, and that's the type of thing that's a type of problem that a company like TrueFoundry is trying to solve, where we aim at making the switching cost from something like an open AI to open source models almost zero. And some people again here alluded to LangChain and retrieval augmented generation and stuff. So we have already done some integrations with LangChain as well. And I gave an example here, right? So if you wanted to use the OpenAI models, the GPTs with LangChain. This is kind of the code that you're writing. From LangChain, import OpenAI, instantiate your LLM object, and then start making predictions. We made this practically the same with the TrueFoundry LLM, where you could be hosting a Llama 2 model, where you instantiate an LLM and start making predictions, basically. Okay. So I think we have a question from Yash. I'm sorry I missed some seconds. Can you please answer my question again? Is it a fight between those who uses more parameters or who can optimize the architectures of LLM? And can you mention some resources where I can decode a complete architecture of general LLMs? So, well, to be completely honest, in general, larger models tend to perform better than smaller models. So there is some merit to saying that folks who are using like models that are much larger will generally tend to perform better than smaller models. Okay. But like it's the way to think about this is, do you need a very large model for every task? Okay. For example, if you were just doing a binary classification, the sentiment of the sentence is positive or negative. You really don't need a 1 trillion parameter model. You could probably just get away with like a 1 billion parameter model and you'll be fine, right? So it's not about one size fit all. You want to figure out which model tends to perform like you need for your data set and how much effort it is to get that model up and running, basically, right? And then the next question is, can you mention some resources where I can decode a complete architecture of general LLMs? Well, to be honest, there are a lot of resources now available online that talk about the transformer architectures and attention architectures. I'm happy to post some in the chat after the session. Okay. So then the next question is, as Llama is open source, that means it would not be pre-trained. Example, Wikipedia dataset, and then fine-tuned if needed. Am I right? I'm not sure. Well, Llama 2 is pre-trained on a lot of public dataset. That's essentially what it is. If you want, you can fine-tune it on your own dataset, just like TrueFoundry fine-tuned it for that multiplication dataset, or somebody in the community fine-tuned it for that uncensoring dataset. You could take a Llama 2 and fine-tune it for your own datasets. Will there be upgrades to next version of Llama 2 to enhance coding and math? Likely. And I think, by the way, there are already some papers out where Meta has released some, well, not necessarily Llama 2 itself, but like some other models that are actually doing much better on coding and stuff. So like, I think there are already some things released. When is it better to fine tune versus zero or few shot learning? Asif asked this question. So this is a very interesting question. Like it's a question that will take me a little bit to answer. There are a lot of factors that you want to consider whether you need to fine tune or you are fine with like, a zero or few shot learning. But just in the interest of everyone attending the call, maybe I'll just take a moment to introduce what zero and few shot learning is. So things that we did here, which is, for example, let me say this example, maybe this one. Okay. So here what I'm saying is, here are a list of people from different cities. Just tell me who all are in San Francisco, right? So I'm basically just giving it a prompt and not giving it any hints on how it can solve this problem. Okay. And just directly asking it a question. Okay. This is an example of zero shot learning, which basically means that I directly expect the model to be able to respond to my question without any further assistance from my side and just an instruction that I'm providing. That's essentially what zero shot learning is. Okay. On the other hand, I can assist the model with some examples of what type of how it can like kind of solve this problem for me. So for example, I could say that in this, so I could enhance the prompt by saying, for example, in this sentence, there is no one mentioned who resides in San Francisco. Okay, because Emma lives in Los Angeles. Something like that. Basically, I'm giving some example to the model on how to reason through it, basically. And then I can always pick up another sentence and I can say in this sentence, Wong is from San Francisco, basically. So in this case, I'm almost like, just like you would teach a kid with some examples, you're basically teaching the model with some examples. Okay, so it's going to, and this is what they call as a few shot learning. So zero shot learning means no further examples. Few shot learning means you're helping the model with some examples. But the interesting thing about few shot learning is it's not actually changing the model's weights. It's not changing the model's model fundamentally at all. It only happens in this session when you are actually asking this specific question. The model learns that, okay, the user wants me to answer based on these examples. Okay. And then lastly, there is a third type of way in which you can affect the responses of your model is by fine tuning, where you fundamentally change the weights of the model. So now it's like a thing that model is really overfit in some way to that task or to the data set that you're trying to work with. That's the difference between zero shot, few shot, and fine tuning. Okay. Now, what are the factors that you would consider when you are fine tuning, right? Number one, do you have a lot of data that you want the model to build an understanding of, or a lot of different specific type of knowledge that you feel like the model does not have from its pre-trained time, basically? You probably want to fine tune it, right? Now, you could also solve it using retrieval augmented generation, but sometimes what happens is that you provide so much context to the model in the retrieval augmented generation that your cost of processing that context every time becomes too much, and you are better off doing the fine tuning, right? Now, on the other hand, there are some downsides to fine tuning, right? Which is if you were fine tuning it for like, this question answering type of a system, there is a chance, like, that you're losing the benefits of grounding that comes with retrieval augmented generation, right? The model might hallucinate a little bit more unless you kind of really block it using very important prompts, basically, right? So depending on what level of accuracy do you need, you may want to choose fine tuning versus RAG type of a system. One other thing that people consider a lot, and this is more of a technical way of putting it, is your precision and recall. Okay. So when you go the route of RAG, retrieval augmented generation, you're kind of focusing a bit more on precision, that only give an answer from these contexts that I have pulled off. Okay. But you may miss on recall. There could be a lot of other context that you never provided to the LLM, so it's never able to fetch the answer from there. Whereas when you fine tune it, you're pretty much giving it the entire data set. So your recall is practically perfect, but you may compromise a bit on precision there. So these are a bunch of different ways, like, factors that you may want to consider when you are fine tuning or not. Okay. Now, I guess a lot of people ask this question, that is Llama 2 the next big thing in AI? Like, should we just, like, all of us switch to using Llama 2? Well, hard to say that. But at least one thing that Llama 2 has done for the open source ecosystem and the larger space around large language models, it shows us that that open source models will likely catch up in terms of the quality of response, right? And the interesting thing is that there's a very rapid innovation happening on top of these open source models. Examples include this uncensored model. Somebody took a 4K context window and, like, built out a Llama 2 with 32K context window. Somebody fine-tuned Llama 2s for specific tasks that even GPT-4 is not very good at, right? So people are really innovating on these models fast because it's available to everyone, all of us. Like, it has like this million minds working towards it. So likely it will catch up and become better on certain aspects as you move ahead. Okay. So whether it's already better or not, it at least gives us the confidence that it's worth investing in open source models and taking a critical decision that which model is good for a particular task, basically, right? And it has essentially given this confidence that, like, a lot of the companies are now starting to invest in open source LLMs to establish like a competitive moat, basically. Because if everyone is invoking OpenAI APIs, there is very little competitive moat that you're establishing over a long period of time. But with open source, you can actually use it in your own ways. That kind of helps you establish that moat a little bit better. That's it. I think those are some of the questions that I had, and those are some of the slides that I had, and I'm now happy to spend more time just answering questions for everyone. And if I have missed any question, Shraddha, that you noticed that I haven't answered, please let me know as well.
Sure. Nikunj, so Asif says, what's the difference between a text complementation model like Darwin and a chat model like ChatGPT?
Okay, got it. So good question, very good question. So in general, you could remember how we explained the language models in the beginning, that the job of a language model is basically predicting the next word. That is essentially a text completion model. Okay. Um, you are basically just completing text. That's all. Like that's a fundamental definition of language model, right? Now, to be completely, and like by the way, like these chat models as well are not fundamentally different. Okay. It is essentially you create a similar text completion type of a task, but the interesting thing that you do there is you do something called instruction tuning. Okay. And an instruction tuning is essentially a data set where you provide a prompt, some instruction as a prompt, that the thing that I told, explain gravity to a 6-year-old type of a thing. And how would you expect a human to respond to that question as your completion, as your response, basically? That's the type of data set that you provide. So the definition of completion in some way is changing. Fundamentally, the architecture of language modeling is not changing. So I think chat models are basically instruction tuned, essentially. That's kind of how you can talk about. Yeah. Pawan mentioned will like to have access to TrueFoundry. I'm pinging my email here, by the way. Folks who are interested in accessing TrueFoundry, please ping me on this email, and I can arrange the access to TrueFoundry for all of you. Then we have Prashant. Prashanta is asking, how can we evaluate the performance of an LLM? Very difficult, Prashanta. Evaluating the performance of an LLM is very difficult for multiple reasons, right? Because it's, as you can imagine, that it's doing such complex tasks that we don't always have good enough data set where you even know what the ground truth should be, right? And when you don't know what the ground truth is, how do you evaluate something? So that's one challenge. Secondly, sometimes even when you know the ground truth, for example, like, give me a summary of this Wikipedia article. Well, you could summarize the article yourself. I could summarize the article myself, and a GPT-4 can summarize the article. Who knows what is correct, right? Who knows how to compare the two pieces of text, basically, right? So on an average, this is a very difficult problem to solve. That said, are we doomed? Do we have nothing to do? Well, not really, right? There are actually a lot of different techniques that people have come up with. So there are metrics like Rouge that you can use to kind of, in general, compare any NLP type of task, basically, right? And then there is a GitHub repository that I would recommend checking out, called OpenAI Eval. And that eval basically has a lot of different ways in which you can evaluate these performance, and they've kind of built out this open source repo. So I recommend checking that out. But yes, it's going to be different from different for different use cases, basically. How much does TrueFoundry cost for entrepreneurs? Are you providing an API? We have an API as well that you could directly start using. We have the playground that we showed, and then we have some of the other things, like you could run TrueFoundry on your own cloud. For example, like if you have like AWS GCP credits, especially as a startup, you could leverage all those credits using TrueFoundry platform as well. How much does TrueFoundry cost itself? It depends on what type of load are you sending, what type of usage are you getting. Like there's a lot of factors that is needed. So reach out to me and we can discuss about that. Okay. How could a vector database improve performance? Well, a vector database, actually, this is again a very good question. I want to take a step back and answer this question in more detail. So far we have talked about language models as almost a repository of even knowledge, if you think about it, right? Effectively, when you ask a language model to define weather or climate, essentially it has memorized the definition of weather and climate, and that's what it is giving to you, right? But as I mentioned, that there is a lot of data that language model did not have access to when it was trained, right? So vector database almost in this case provides like a separation layer of data and smartness to process that data. So the language model comes with the smartness to process that data, and your data itself remains in a separate database, basically. So it separates out your knowledge and the smartness in some way, right? Now, when a user query comes, you first take the assistance of a vector database to find out the most relevant pieces where the context could be there. So now you have giving that context to the language model, and then ask the language model to use the smartness to answer that user question, basically, right? Now, obviously, vector databases are very optimized to be able to do this kind of fuzzy matching. They call it approximate nearest neighbor search and stuff like that. But fundamentally, that is where I feel like vector databases add a lot of value. Okay. If we consider LLM application in e-commerce and digital advertising domain, what its future in terms of handling very large data sets and giving accurate results? I think it's hard for me to answer this question without knowing a bit more about what is the task that you are trying to do. In general, large data sets is not a problem. And I could at least tell you from experience that many companies that we work with or talk to use LLMs in digital advertising and e-commerce. In fact, that's one of the primary applications of it. Whether it will work in whatever exact problem you're trying to solve is really debatable. So I don't know, at least at this point. Can you talk about opportunities or gaps that still lie to be solved for LLMs? There's a lot, right? And I think at least one thing that is there on everyone's mind is hallucination. And somebody else asked about hallucination as well. So far, LLMs operate in a relatively mysterious fashion. Okay. The least I can tell is we don't, as a community, we don't have a very good understanding of where is the LLM fetching the answer from. It's a research field right now. For example, when you think about CNNs, right? I'm taking a bit of a digression here to explain this point. When you think about CNNs, and only folks who come from computer vision background may be able to understand this, but I guess you can at least read this mental model later, right? When you think of a neural network architecture, the CNN, you actually understand what's happening in each layer of CNN. That the earlier layers of CNNs understand from your images some edges or patterns from the images of the separations, edges, etc. Then the next layer would understand some more features like whatever, like your eyes or ears or lips or nose, etc. If you're doing a face identification. Next layer would start mapping like regions of your faces. And the last layer would say that, okay, here's the face of whatever, John Abraham, and here's the face of the pickup Padukone, whatever, right? So that's what happens. So we have a pretty good understanding of what CNNs are doing under the hood. So far, we don't have that good an understanding of what LLMs are doing under the hood, right? All we understand is attention in some way. So I guess that's one major area of innovation that's still left to unleash. That how can we control the output of LLMs, and for that we really need to understand that. That's one. The second thing is realistically, what's happening is it's all sequence to sequence right now, right? Like a sequence of something as an input and a sequence of something as an output, right? Are there other modalities that can be covered? Because right now, because the way LLMs are designed, we actually think to model all the problems as sequences. I don't know, like could we process graphs directly more natively within LLMs at some point? That's an area of research, right? And then from a practical standpoint, as you know, that it takes like thousands and tens of thousands of dollars to still build production grade systems with this, like train these models. And ideally that cost really needs to come down for this to become more fundamentally, like more widely usable. And last point, by the way, being LLMs today are great at building demos, cool demos. But when you start using them in production, you realize that there's a lot of moving parts. Things break for many reasons, and that's the other thing that will get fixed in the next few months to the next few years. How far are LLMs on working on encrypted corpus, encryption in use, not rest or transit? I don't know. I actually don't know much about this side, to be honest. So only want to give answers that I feel more confident of. Apart from RAG and LangChain, how to fine tune? Well, there are some first of all, TrueFoundry can help you fine tune. So if you have actually a fine tuning use case, reach out to me and I can probably help set up a call where you could fine tune your models. But besides TrueFoundry, there are other solutions as well. You could use AWS SageMaker. They have a product called Jumpstart. You could use that. There is another company called Replicate, which exposes some fine-tuning APIs. And by the way, you could also spin up a Google Colab notebook and just run your fine-tuning yourself as well if you want to, right? is it possible to develop our own internal LLM to avoid data security issue? Well, you don't need to build your own internal LLM to avoid data security issue. You could technically run one of the open source models in your own cloud. So your data never leaves your cloud. Building an LLM from scratch, as I mentioned, remember how I showed that Facebook costed $8 million just for GPU time to Facebook to build a 70 billion. So if you want to go that route and you have that kind of resource, and you can justify the need, feel free to train your own LLM, but otherwise just take one of the open source LLMs and run within your own infrastructure. Last two questions. How crucial was discovery of transformers to see the level of LLM performance that we see today? I think, well, look, the entire LLM is based on transformer, by the way. Okay, that's the fundamental architecture. Everything else is almost like a cherry on the cake. Maybe I'm trivializing this. It's a very big cherry on the cake if you wish, but the fundamental architecture remains transformers, right? So I think that was the actual fundamental building block to see all the innovation that we are seeing today. Credits to Google on open sourcing that attention is all you need paper. That said, can we think of an alternate reality where transformers did not come out the way it did, and maybe some other route could have taken to this innovation? Who knows? Right? Like we'll get philosophical trying to answer that question. Last question. Agents in LLM has made a big difference. Do you think agents could be integrated within LLMs without externally having to work with LLMs? That be processing tabular data. I'm trying to understand this question. Agents in LLM has made a big difference. Yes. Do you think agents could be integrated within LLMs without externally having to work with? I don't know. It's intuitively, it's very hard to imagine what does it mean to have agents integrated within LLMs. Okay. The whole point of agents, by the way, is that you are able to augment the capability of LLM using something external, right? Either data sources or some tasks or some APIs that you have built out, basically, right? So to me, it does not make much sense about what would it mean to have agent integrated within an LLM, by the way. And for sure, please feel free to connect with me on LinkedIn. I have heard from some people that you need to enter the email address for connecting with me on LinkedIn. So I'm just sharing my personal Gmail and my work email as well. So feel free to send out a request to me on LinkedIn and we'll connect. Once again, it was great chatting with all of you. I really enjoyed the session. Great questions, makes me think, and I'm going to take a few questions as homework as well. And feel free to connect with me, reach out if you need access to TrueFoundry. Would love to work with you all. Thank you so much, Shraddha, for having me over here.
Thanks, Nikunj. We sincerely appreciate you conducting today's webinar, and your expertise and your insights have enlightened the entire crowd. We're grateful for you sharing your wealth of experience, and thanks again for a very remarkable and enlightening session. Reiterating to what Nikunj has already mentioned, Nikunj is actually the co-founder of TrueFoundry. And what TrueFoundry does basically is they're an MLOps and LLM Ops company, wherein they help other companies' ML project get deployed. If you wish to, as Nikunj has already mentioned, if you wish to see a demo of TrueFoundry, you could contact us as well, and we will put you through Nikunj, or you could contact Nikunj directly, whatever works for you. That's about it. Thanks again, Nikunj, for driving this very informative webinar, very captivating, informative webinar for
Thank
us,
you so much.
for our audience.
Really appreciate this, Shraddha. Take care. Bye-bye,
Thanks, you
everyone.
too.
Thank
You
you.
too. Bye-bye.